Swayam Prabha. Digital India. Educated India.
We mentioned this definition of common knowledge in passing, and I kind of defined it, this notion of common knowledge in a kind of informal way, because I use words like event, I use words like know, what does it mean for what I said that okay, player I knows that, player J knows that something, and so on. All of this was done in a kind of heuristic way. Okay, so now what we will do is we will make this formal, okay, and we will talk about what we will make in a very formal way. What actually do we mean when we say that a player knows something? Okay, all right. So the typical sort of situation that we want to talk about is that there are many different possibilities in which the actual world can exist, but different players have different pieces of knowledge about it. Okay, and now from that knowledge they want to talk about not just about what the world actually, what the state of the world actually is, but also what knowledge the others have about it. Okay, so we need, that is what this framework is going to help you do. So this framework will help you answer questions like what does player A know about what player B knows, and then recurs on that, like what does player A knows about what B knows about what C knows, and so on. Okay, so I'll give you a simple kind of example. Suppose there are these two players, John and Paul. These are these two players, and John is colorblind. Okay, and I'll define what colorblind is. So John is colorblind, and everybody knows that John is colorblind. Okay. About Paul, we don't know actually if he is colorblind or not. So there are two different possibilities. He may be colorblind or he may not be colorblind. But when he is colorblind, he knows that he is colorblind. Okay. For Paul, there are two possibilities: colorblind or not colorblind. But when he is colorblind, he does know that he is colorblind. And when he is not, also he knows that he is not. Okay. So, but only Paul knows that he is colorblind or not. Now, why are we talking about colorblindness? The reason is because these two players are looking at a car race. Okay, there are cars of three different colors. Purple, red and green. There are these three different color cars. Suppose they are racing. Okay, and they are both watching that finish line, and they can see some car pass. Now, based on their own impairments, they will be able to say whether or not a particular car has won. Okay, a colorblind person, basically means that he cannot distinguish between red and green. So, a colorblind player cannot tell the difference between red and green. Okay. So, which he cannot distinguish between red and green, which means that if a purple car does win, okay, then that fellow will be actually able to tell that it is the purple car that has won. But if it is red, if it is either red or green that has won, you will not be able to tell which of them has won. Okay. Now, let us say for instance, this is some kind of, based on this they are going to decide which car to buy or which car to bet on or something like that. Okay. So, this is part of, this is eventually linked to some decision making at the end, but we are not even talking about that decision making. Here we are just discussing who knows what. Okay. So, try to answer a question like this. So, suppose it is that the red car has won, then who knows what about this? So, if John is colorblind, okay, John cannot tell, he just knows that purple has not won. Okay. Now, for Paul there are two cases. So, just like I told you that the red car has won, I have to also tell you what is Paul's state, whether he is colorblind or not colorblind. So, now suppose Paul is not colorblind, let us take it for simplicity, Paul is not colorblind. Okay. Then what does Paul know? Red car has won. Okay. What else does he know? Now that he knows that the red car has won and he knows also that John is colorblind, he also therefore knows that John does not know which car has won. Okay. But he does know that John knows that the purple car has not won. Is this clear? Right? Okay. Anything else? What does John know? No, not necessarily. See, John does, okay, let me ask you a pointed question. Does John know that Paul knows the color of the car? He just knows that Paul knows that it is not purple. But he does not know that Paul actually knows the color of the car. Why? Because Paul's color blindness is known only to him, okay, but not to John. John's color blindness is publicly known, it is common knowledge. Right? Okay. So, just now I just talked about, we just asked, okay, first we asked what do each of them know about which car won. Then we asked, okay, what does each person know about what the other person knows about the car that has won. Now I can ask one more level. So, what does John know about Paul's knowledge of what John already knows? John knows that, yes. So, right. So, John knows. So, if it's the red car that has won, John knows that Paul knows that, yeah. No, but Paul knows, Paul knows that that John doesn't know the color. Paul is not colorblind. So, Paul knows that Paul knows that John doesn't know the color. Okay. Does John know that Paul knows that John doesn't know the color? Why? Yeah, John is colorblind, that everyone knows. But what, let's, okay, that he knows that it is, okay. Yeah, so this is trivially true because John is colorblind and everybody knows. What about the reverse? Yes. So I have to, that's why I cannot, it would be recursive if I said that it is common knowledge and then tried to define common knowledge, right. So that's why I am motivating this sort of, let's say, heuristically. Okay, but anyway, the point is, before we get into more of these loops, the point is that we need a framework for this kind of hierarchical, knowledge structures, that we ask what does each player know of something, and that something itself could be what another player knows. Is this clear? Okay. So, the very beautiful and elegant framework for doing this, and that framework is what is called, is due to Aumann's model of incomplete information. So the model actually comprises of the following. Okay. So first, what we have is let's call this set S, or maybe, yeah, let's say call it S. This is a set of states of nature or states of the world. Okay. So the world is in one of these states. You have n players here. Now, we are going to assume that players get knowledge about the state of the world through some kind of observation. Okay, so this is the kind of framework that we use in control theory, physics, information theory, and so on, where your knowledge that you have is through an observation. Now, what does this mean? This observation basically tells you up to a certain level of granularity what actually is the state of the world. If you have perfect observation, it will actually tell you the exact state of the world, but otherwise it will tell you up to a certain level of precision what the state of the world is. Okay. Now, the way to model this is to say, well, that for every player I, you have this calligraphic Fi. This here is a partition, of the set S. So, the S I used for strategies. No? So, let me just change this to something else. I will just call this Y. Okay. So, Fi is a partition of Y, okay, for each player I. Now, I will tell you what this partition means. Okay. Now, what this says is this. Suppose this is your set Y. This is all possible states of the world. Okay. Now, what player I, a partition basically means a division of Y into subsets, such that each of these subsets, they are mutually disjoint and their union is Y. Okay, so you divide Y into these into disjoint subsets whose union is the full set Y. Now, when an actual state of the world, let's say omega here, gets realized, what a player, this particular partition is for player I here. Okay, this is player I's partition. Now, what player I knows is that the state of the world is one out of this element of his partition. It's in this yellow region, but he doesn't know which exact point in that yellow region it is. Okay, that's what so the partition basically captures this ignorance. It tells you that what is the granularity to which a player knows about the state of the world. Now, so if omega is the true state of the world, which is this point, player I only knows this. Now, there could be another player J who has a different partition. Okay. Every player has a partition, and these partitions could in general be different, right, because their way of measuring the world and or whatever measurement apparatus they have, the measurement information channel they have, whatever it is, or that is different, and so therefore they get a different partition. What does this mean? That means their amount of their knowledge could be about the state of the world could be different. For example, for another player, this could be a partition. So, I have now again chopped up y into a different set of subsets which are mutually disjoint and whose union is y. Okay, the blue one is for another player J. So, this here is for player J. Now, when this gets realized, when omega gets realized, what does player J know? Player J only knows that it is one out of this green shaded region. But not which one out of that. Is clear? So, this is our way of expressing the knowledge of the player. Now, why does this make sense, and where does this partition come from? See, this partition is basically, so this is, as I said, it's like a control theory or physics or information theory type model, because our way of thinking about what does a player know is basically that player knows about the world when he measures it. Now, for example, if you want me to, if I want to know if I have fever, I have a measuring device such as a thermometer. I check my temperature. Okay, the temperature is a particular output of my this thing. What I can conclude is I am in one of the states that leads to that temperature. Right? It could be that I have fever. It could also be that I have maybe something else, or it could be that I have just run a lot, therefore my temperature is high right now, could be whatever, right. So, the actual state that I am in is in one of these y's. My measurement device only tells me the inverse image of my this thing, it just tells me. So, if I have a measurement device like a thermometer, say thermometer basically will map all my body states y to a temperature, let us say some 0 to whatever, 0 to infinity, right. So, and when I get a reading T as my temperature, what I know is that my body state is actually just one of these H inverse of T's. Right. So, if I get a reading as, if I get my reading is 100, I know that it's one of these H inverse of 100. If I get my reading as 99, I know it's H inverse of 99, etc., etc. Now, you can see that as I vary T, each of these sets is going to be disjoint, because they could not have possibly given me the same temperature, right. These are disjoint sets. As I vary T, actually what I end up generating is a partition of my space y, because I keep, for every T I get a different H inverse of T. This generates a partition of my state y. It basically, and it partitions my whole space into subsets of that capture my level of ignorance. So, all states, so in particular let us say this one here, if I take this one here, this corresponds to all those y's, this corresponds to all y's, all omegas such that h of omega is equal to say 100. These are all those omegas for which h of omega is equal to 99 and so on, right. But if I go to another person who maybe someone who has a different measurement device, maybe a more accurate thermometer, or he does another test altogether, he can get a different reading and a different partition. Okay, a different reading means not just a different numerical value, but also a more accurate potentially reading, or a reading that gives him more visibility into some states that just my temperature based measurements was not giving me. Correct. So, this is essentially our way of modeling knowledge in a game. Okay, this is exactly how we model knowledge or information even in a control setting, because there also you get what you get is you have a certain state, underlying state, let us say x, and what you measure is some function of that state. Okay, this is a usual measurement equation where you get what the output that you get is equal to some function of that state, So what you can tell is that this, when you get a particular measurement, a particular output, all you know is that the state is such that it would have led to that measurement, but you don't know which exact state, right. So it basically partitions the state space based on the values of the measurement. Okay. All right. So this basically is our model for, this is our underlying model. Now from here, how do we conclude what each player knows? We can talk about that, but before that, let's try and do an example. The previous John and Paul example, let's try to model it in this way. Okay. So now in that case, you remember there are 3 different cars, purple, red and green, that could have won, and 3 cars, purple, red and green, and there are 2 possibilities as far as Paul's color blindness is concerned, right. So that means Paul is color blind or not color blind. This is for Paul. Okay. So now in this case, therefore, the state of the world is in 6 possible states. The 6 possible combinations are this. So Y then comprises of these 6 possible combinations. You have that Paul is color blind and the purple car has won. Paul is color blind and the red car has won. Paul is color blind, the green car has won. Paul is not color blind, purple car has won. Paul is not color blind, red car has won. Paul is not color blind, and the green car has won. These are the possible states of the world. Okay. One of them is going to be the true state in which we will be analyzing the game, but these are the possible states, right. Now, if these are the possible states, then what does each player know? Let's try to understand that. So let's look at John's partition. Okay. Now, what is John does not know, okay, if Paul is color blind or not, and also John himself being color blind can only distinguish between whether the purple car has won or not won. Okay. Now, what we will do is what this means is that if you look at this partition that you have that I have drawn here, it should have the structure of this partitioning should be such that all those states that John cannot distinguish between should be in one subset, right. The states that he can definitely has a way of distinguishing will have to be in a different subset. Okay. So now out of these states, which ones can John not distinguish between? So one, of course, at one level he can say that Paul is color blind or not. He does not know if Paul is color blind or not, right. So then therefore you can say, well, all color blind, non-color blind can be put in one set, but then that is not fine enough, right, because he knows a little bit more than that. So you have to go to the exact definition of the state. See, the state here says a combination of Paul's color blindness, yes, no, and the car. So what combinations now can he distinguish between and what combinations can he not? So let's suppose when the purple car has won, he can tell that the purple car has won, right? But he cannot tell if Paul is color blind or not. Now, what does that mean? That means he cannot distinguish between this state, which is color blind, purple, and not color blind, purple. Right? So these two have to be in the same subset. So this must so there is a subset here which I can form by using these two states, color blind, purple, and not color blind, purple. Okay, all right. What else? Now, all the remaining ones, what do all the remaining ones capture? It's either red or green that has won, and Paul is either colorblind or not colorblind. He has no way of telling, any of them apart, right? When green wins and Paul is colorblind versus when red wins and Paul is not colorblind, all of them are, for him, they are alike. Okay, so all of these are in one this thing, which is, so colorblind comma red, colorblind comma green, not colorblind comma red, not colorblind comma green. So you can see this is now his partition. What do I mean by the partition here? The entire space Y has been divided into two sets. This is one set, this is another set. They are disjoint and their union is Y. Okay. So and when one of these occurs, John can only say about which partition has actually occurred, but not the exact state in that partition. So, for example, if this state comes up, he only knows that one from this box has come up, but not which exact one. Okay. What is the corresponding one for Paul? So, Paul can tell whether he is colorblind or not. Okay. What does this mean? See, since Paul knows he is colorblind or not, then you cannot have the following situation where you have a particular car has won, the same car color, but colorblind and not colorblind come and put in the same set, right? You cannot have a combination like this. For example, you cannot have a combination where colorblind comma purple and colorblind comma not purple in the same set, because Paul knows whether he is colorblind or not. He should have been able to distinguish between these two sets. Okay. But of course, when he is not colorblind, he may not be able to distinguish between the colors of the car, which is a different matter. That's not what I am talking about, right? So, you cannot have, for example, colorblind and red and not colorblind and red in the same set. Okay. So, what exactly is his partition? Let's write that out. So, let's go one by one. So, colorblind and purple, when he is colorblind and the purple car has won, can he tell exactly that? Okay, so he knows. So, this set is a singleton set by itself. So, when this happens, he knows exactly that has happened. Okay. What about colorblind comma red? So, he cannot distinguish between colorblind comma red and colorblind comma green. So, when he is colorblind, he will not be able to distinguish between these two. Okay, so these and colorblind comma green are in one set. When he is not colorblind, he can distinguish all of them, all the car colors. So, all of these are then in separate sets. Right. So, this is now Paul's partition. Okay. So, when any of these occur, he of course knows what the state of the car is. Likewise, this one also. When this one occurs, he only knows that one of these is occurred. Okay. All right. Okay. So, I will just set up some more notation then. Now that we know this. So, the way we will analyze further is that what we will pick a particular state of the world, okay, and that state of the world is known to us as observers, okay, but the players may not know. Okay. So, this is what a situation. So, what I wrote out above is the model, but a situation of incomplete information comprises of a particular state omega star and y. Okay. Now, when omega star occurs, what do players know? So, let us define this. So, this simple f of omega, this is the element of this fancy Fi that contains omega. So, this simple Fi is the element of this fancy Fi that contains omega. Okay, from that, so it's the element of the partition that contains the actual the particular state. Okay, so in a situation where omega star is the actual state of the world, Fi of omega star is what players know. That is their level of knowledge. Okay. Okay. Now, players will be talking about, we will be talking about knowledge of players of events. Okay. Now, what is an event? An event is simply a subset of y. Okay. So, you take any subset of y, that's what we call an event. Okay, and now we can discuss of what do players know about this event and so on. Okay. So, for example, let us take this subset. The subset is that let us say color blind, comma green, not color blind, comma green, okay. So, can you tell me what is this event? Example. In words, can you tell me what is this event referring to? See, an event is just a collection of states of the world, and the event is, when you have this collection, it's an or between those states. So, okay, it's either this or this or this. That is what we are calling as the event. So, this here, so for example, this event A here is the event that either Paul is colorblind and the green car won, or Paul is not colorblind and the green car won, or Paul is colorblind and the purple car won. Okay. So, in short, I mean, I can summarize this is, it's the event that either the green car has won or Paul is colorblind and the purple car won. Okay, that's this event. So, okay, so this is either green car won or Paul is colorblind and the purple car won. So, I have to be careful and right. I am putting this in brackets because I want to make sure the and is between those two last two things. Okay, all right. So, now this is an event, and we are talking of an event in when in a context of a certain situation, right? That is, situation means a particular state of the world has been chosen, and now in that context we want to talk of a particular event. Now, it is possible that this event itself is not occurred in the particular state of the world, right? For example, if the situation that we are talking about is that Paul is color blind and the red car has won, if that is omega star. So, omega star is, so if omega star is this, color blind and the red car has won, then this event has not even occurred. right, because none of the possible states of the world that that event refers to is equal to omega star. Okay. So, the true state of the world is omega star, but the event that you are referring to has not occurred in this state of the world. Okay. So, that is why we need another terminology. We say that an event occurred, actually occurred is a bad word in English because it seems like it is, it's also known that it has occurred. So, that is why the word used is event, we use the word obtains. We say that an event A obtains in omega star if omega star belongs to A. Okay. So, you have a state of the world and we say that an event A obtains in this state of the world if that state of the world is present in is an element of that event. Okay. Okay. So, obviously, it makes sense to, when you are in a particular situation, that means you are discussing a particular state of the world as the true state of the world, it makes sense to discuss about events that have actually occurred in that, right. So, the others that are not occurred or that have not obtained are kind of hypothetical, right, in some sense, that they could have occurred, but they are not what is being considered in this situation. Okay. So, I will end with one last definition. So, we say that player I knows event A in state of the world omega star if Fi of omega star is a subset of A. Okay. So, we say that player I knows that event, okay, or whatever, knows that event has occurred or knows that whatever that event represents in a state of the world, in the situation omega star, if Fi of omega star is a subset of A. Now, what does this mean? It means that, go back to what Fi of omega was, it was the element of his partition that contains omega star, right, is the element of his partition that contains omega star. Now, if that element, so all his ignorance about omega star is captured in Fi of omega star. So, he knows that the state of the world is one of Fi of omega star, but not which one. Now, if that is a subset of A, okay, then it essentially tells you that what it means is that he knows definitely that he definitely knows A, okay, because he knows from his information, he knows that he can conclude that one of A has occurred for sure, because he knows that one of Fi of omega has occurred and Fi of omega star has occurred, and Fi of omega star is a subset of A. Is this clear? So, that is our model for knowing a particular event, alright.